Good evening. Welcome to the first of our wonderful Geschke lecture series. My name is Bob Greenspan. I chair the board of the Athenaeum, and the Geschke lecture series is, of course, one of the programs that the Athenaeum puts on during the summer. This year we're going to have 4 outstanding lecturers. I know some of you think that the start of the summer is the 4th of July fireworks, or maybe it's the film festival, or even Fagawi. But for me, the beginning of the summer really is the first Geschke lecture. Chuck and Nan Geschke have done a number of really wonderful things for the island of Nantucket. This is a particularly exciting endowment that they have given us over the course of 9-10 years, maybe. We've had a group of remarkable speakers, and this year is going to be no exception. Our speaker tonight is David Mindell, and what we try to do in this lecture series is come up with provocative and interesting topics. Our audience on Nantucket is extremely sophisticated. We want to make sure that we are stimulating and providing you with thoughtful and insightful speakers. Tonight we're going to talk about the relationship, David's going to talk about the relationship between people and machines. And it's quite an interesting subject. In my own world, 2 of the greatest things that happened in my life are the ATM machine and the Easy Pass. When I was a young adult, I had to stand in line a long time to get cash from a teller and wait in long lines on the interstates to pay my tolls. And now both of these are facilitated by machines. Self-driving cars, we've read a lot about them, including an accident recently. Planes that fly themselves. I actually sat in the cockpit of an aircraft landing at Heathrow 10 or 15 years ago, Category 3 landing, completely automated. Pilots sat there looking at the controls, ready to take over if they had to, but the plane flew itself, couldn't see anything, landed, the throttles went forward all by themselves. Quite remarkable. Stephen Hawking has said that the development of full artificial intelligence could mean the end of the human race. That's quite a provocative and interesting idea, and I think our speaker tonight will be able to help us understand whether Hawking is right on that point, or maybe it's a little more complicated. David?
Thank you for that introduction. It's of course when I was asked to come speak here, it's a terrible hardship to me to come to Nantucket in July. I did have to leave Aspen yesterday a little bit early to get here. Is the microphone working? I did have to leave Aspen yesterday a little bit early to get here, and nobody back at the office is really sympathetic to my complaints about a lot of travel. But thank you so much for the invitation. Beautiful dinner just now. Thanks to Chuck and Nan for sponsoring the series. It's just always a pleasure to come speak to a group of interested people in a topic that, when you write a book, you sort of slave away by yourself for a lot of years. And then the book comes out and it's kind of one's gift to the world. Sorry, everybody.
And in a funny way, it actually feels like I'm coming back to my old neighborhood, because as you'll see, a lot of the work that inspired me to write this book and even the things that I talk about in the book happened just down the street in Nantucket Street terms over at Woods Hole, which is only about 20 miles as the fish flies from here. When I lived in Woods Hole, it was often a great sailing destination to come to Nantucket. So I'll start with a little bit of a story about spaceflight. About 8 or 10 years ago, I wrote a book called Digital Apollo, which was about the computers and the automation and the software that landed on the moon. And those computers were built at MIT, and so it was, that's where I teach, and so it was easy for me to interview all the folks who had written that. And what was really interesting about that story was that when NASA first came to MIT in 1961 and said, the president wants us to go to the moon, we'd like you to build the computer to get us there, the engineers said, well, you know, we can do that. That sounds like a tractable problem. The interface on that computer really is only going to need 2 buttons. And this is literally true. And those 2 buttons are going to be go to moon and take me home. And now, this interface actually looks a lot like what some of the driverless car companies today are saying is going to happen in driverless cars. And in some way, what my book was about was over the course of 1961 to 1969, when Neil Armstrong and Buzz Aldrin landed on the moon, you had this extremely rich development, and the landing was very heavily computerized. It was very heavily dependent on software. It was the first use of digital fly-by-wire, which is what is common in airliners today, where everything the pilot does goes through the software and the digital computer before it actually controls the aircraft. But what it actually looked like was this image here. Actually made for me by John Knoll. I was telling Chuck about that, who also created Adobe Photoshop. And this is a computer graphic image of what you would have seen if you were Neil Armstrong about 500 feet above the moon when he's reaching his hand up to turn off the automatic targeting system and land with his hand on the control stick. And you can see, that doesn't come up so well on the projector, there's a crater there. And what you ended up with, and you can count the switches and dials there, is this very, very rich kind of multi-layered interface. The legend, as the New York Times told it the next day, was that Armstrong turned off the computer and landed by hand. That's not correct at all. He turned it off from a kind of highly automated automatic targeting mode to an only slightly less highly automated mode, where he was still very heavily aided by the computer. But I think the key point was that the human was there, and the computer and the control system allowed him to choose what level of automation he wanted at the moment, based on the circumstances, based on his own assessment of the situation and what he saw there at the moment, which really wasn't that able to be foreseen ahead of time. And the book goes into that in a lot of detail. And after Armstrong did this, all 5 of the following attempts at a lunar landing did the same exact thing, and they were all successful. So of the 6 attempted landings on the moon that the US did in the Apollo program, we were 6 for 6. Apollo 13 didn't go so well, but they didn't actually attempt the landing because of the other problems. And that really got me thinking, and partly I saw this from before, of this general thing about there's an idea that a lot of my engineering colleagues have that somehow the highest level of technology, the thing that we should be shooting for that's really the ultimate progress, is this kind of thing. But when you actually look at how people use systems in the world and what really evolves, you end up with these much richer kinds of things. And when they're successful, they tend to look like this more so. Now, of course, that's 40, pushing 50 years ago. And people can say, well, that's old technology. But what I did in this book, which is the one that really brings me here today, and came out last fall, is look at a whole bunch of different areas, particularly from extreme environments. Undersea, where, as I mentioned, I started my career, aviation, spaceflight, warfare. These are places where the environments are so hostile that we've had to use robots for 30, 40 years in some cases. I have friends at Woods Hole who operate robots 200 days a year for the last 25 years. Right? Robots are not new in human life. They're going to be relatively new on our highways, in our homes, to some lesser degree in our factories. But partly I set out with this book to say, what have we learned from all those extreme environments, and what happens when robots become ordinary and routine? How do they change the nature of these work? And as I mentioned, what you see is these systems tend to become less autonomous as they're situated within real systems of human work, human labor, and getting things working. And then I conclude from that, what we really want is not necessarily full autonomy, which doesn't even really exist. And I'll explain more about that in a minute, but what I call situated autonomy, where you have autonomous robots that live within human environments that are able to work, live alongside us, and do what we want them to do when we want them to do it, and not do what we don't want them to do when we don't want them to do it. That's not at all a simple thing to achieve. But I feel if we think about the progress of technology, it's in many ways a higher level of progress to achieve true fluid interaction. There are no robots in this room today, right? Robots do not do a good job of living in human environments today. They do a very poor job. And so I go through in the book a bunch of different stories, and I'll tell you one from the deep ocean. When I worked at Woods Hole, I worked in a lab, very exciting lab called the Deep Submergence Lab that was headed by a guy who you've probably had speak here, Dr. Robert Ballard. And Ballard was a geologist who worked for the Navy in the 1960s and 70s, and he worked at Woods Hole with a vehicle called Alvin, which you may be familiar with, a 3-man submersible. And around 1980, he got interested in the idea of maybe we can have remote presence of the ocean.
Maybe we don't need to send our bodies to the bottom of the ocean to study the seafloor. Maybe we can do it remotely. And he came up with this idea.
Which was actually it's from 1981. I think it's not a coincidence that Ballard came up with it when he was on a sabbatical at Stanford. So he's surrounded by the kind of beginnings of the personal computer revolution, early fiber optics and whatnot. And he says there's a vision of a ship with a remote kind of towed sled that's connected by a long cable to the ship, and then a little robot that kind of wanders off from the ship. And then you can't really see it very well here, but there's one person surrounded by monitors in a kind of virtual reality type environment, also connected to people on shore via satellite. And it's really a very forward-looking sense of connected remote virtual presence. Now you can look here and you can go, you know, in some kind of cartoon sense, this is the robot. This is what we always refer to as the robot. But the whole system is kind of a robot, including a manned vehicle, a ship, and remote different kinds of vehicles. Now they built this system in stages. This image appeared in National Geographic in 1981. It was published. It's still on the wall in Ballard's office at the University of Rhode Island today. And they built it in stages, and this towed sled was the first thing built. And this sled is the thing that found the Titanic in 1985. So the Titanic was not found by oceanographers, you know, laying their lives on the line by diving in Alvin to go to the seafloor. It was found by a remote camera sled, basically a remote robot. This is a big, you know, mindset change for oceanographers who are used to visiting the seafloor. Now, interestingly enough, in 1986, the following year, they took the early version of the little robot called Jason Jr., and they connected it to Alvin, and Alvin then landed on the deck of the Titanic, and Jason Jr. then went down the grand staircase of the Titanic. And I show you these two images because they're so different, right? On the right side, Time magazine cover, you see Alvin there, and the robot isn't even pictured. Which is why I think most people today still think Alvin discovered the Titanic. It did not. It explored the Titanic a year after it was discovered. And in the National Geographic version, which Bob Ballard wrote the article so he could control the cover, you have only the little remote robot. So there's a tension here between what's human, what's remote, what is the way that we explore. People have different views of it. And actually, the robot engineers and the Alvin engineers, even though they had to tie their systems together on this expedition, they did not get along well. And they there was literally tension in this little cable, but also within the submarine about whether it was remote versus human presence. Now, need I remind you, of course, the fictionalized version of this scene is the opening scene of the second most popular Hollywood movie ever made, Jim Cameron's Titanic film, where he uses this very scene as a kind of metaphor for diving into the wreck as a way of going into the past story. So you again get from this is back in the 80s, but maybe the robots aren't really kind of cleanly moving from the human systems.
Maybe we're going to live in a world where we have human vehicles,
i.e. ships, submarines, mixing with remote vehicles, and the lines really aren't all that clear. This is really the kind of question that started my career. Here's a family tree of vehicles from Woods Hole, and it implies this kind of older version, I think, of progress. You have Alvin down here. Alvin's been diving since 1964. Here's little Jason Jr. that went inside the Titanic. Here's Jason, the first kind of full-size remote robot that I worked on starting in the late 80s and in through the 90s. Jason 2, a family then of these autonomous vehicles here. They don't have cables to them. These are called Remus Vehicles. There's a company now on the Cape called Hydroid that makes them. They found the wreckage of the Air France 447 crash. Actually, that's the opening scene in the book. Other vehicles that my colleagues have made. These are all quote-unquote autonomous vehicles. And again, we thought, okay, you're going to go from manned to remotely operated to autonomous. That's the natural progression of technology. That's the natural way of the world. But that's not really how it happened at all. In fact, all these vehicles are still being used. Alvin Woods Hole just spent a good part of its endowment to build a new version of Alvin. We're still diving people to the seafloor. We're still diving remote robots to the seafloor. And we're still diving autonomous vehicles to the seafloor. So you have this hybrid mixture, much more than a progression toward the fully autonomous.
These vehicles up here, actually, Nereus,
are also hybrid. They're both remote and autonomous at the same time. And they hold the world's deepest record for the deepest human-made object to dive and then return. It was set by a manned vehicle called the Trieste in 1961 with 2 Navy sailors in it. And then they broke that record in the Marianas Trench in 2012 with one of these hybrid vehicles. The future then looks a lot more like this, where you have kind of hybrid autonomous remote vehicle. You have some communications to the ship. You always want to talk to it if you can. It's almost never fully autonomous because you're always in touch with it. It's an expensive toy. You do not want to lose it. Even though there's no people on board, nobody would die. You don't want to lose this expensive toy. And so there's different kinds of remote modes. You have different kinds of ways of talking to it. You may be able to talk to it. There's some really interesting novel technologies of light communications coming out. You may talk to it through a buoy. And these are all these kind of funny hybrids of, is it manned? Is it unmanned? Is it remote? Is it not remote? Is it a robot? Is it not a robot? This is much more what I think the present in the ocean looks like and the future in a lot of our world looks like. When you think about robot, you've got to think about a robot as connected to all these different things and stop thinking about it as a little human person that has a cute little face and talks to you like your kid might talk to you. Much more a kind of physical extension of the digital world and these kind of different places. Okay, why is that important? What does that mean? Well, it means that in a lot of places where people are worried about us taking people out, and robots coming and killing us or taking over, what you really have is you're moving people around. And decisions that were once maybe made by a pilot are now made by a programmer. Decisions that were maybe once, we saw this in Dallas last week, made by a police officer with a gun are now maybe made by a police officer remotely with a robot, but still making a decision. In that case, the robot didn't decide to do anything. The police decided to do something, and they used the robot as a remote tool to do that. So the rest of the book looks at this issue in a bunch of different areas. The undersea one is the one that I have the most personal experience, but I've done research in a lot of other ones. This one here is the control station for the Predator or the Reaper drone that's been used for targeted assassinations in Afghanistan and Iraq and other places. Very, very important development. Very, very interesting, complicated change in warfare. Not everybody agrees with it. There's a whole set of political and ethical concerns about it. But what that system is not is an inhuman remote robot making decisions to kill people on its own. Initially, the Air Force called that system an unmanned aerial vehicle, UAV. They actually had to ban the term unmanned because it takes 150 plus people to operate one of those vehicles, okay? They're all over the world. They're all spread around through networks. They're in different places. They're never actually in one place. But the Air Force won't use the word unmanned. In fact, the biggest problem with these robots is personnel, getting enough people to fly them and keeping them from getting too stressed by the experience. So it's a very human system. Wasn't designed that way, just like the Apollo system. It was designed to have no ground station at all, no interface at all. Why would you need an interface? It's unmanned. And instead you end up with this interface, which you talk about in the book, which has
16 different LCD screens and 8 different keyboards.
And it's not very user-friendly, but it's a very rich artifact. Similar issues in commercial airliners, where actually a number of airliners are moving away from these fully automatic landing systems that we heard, more toward heads-up displays, which in the entertainment world today you'd call augmented reality, because it keeps the pilots much more deeply engaged in what they're seeing, and they land kind of through the computer. It's not that they're not dependent on software. It's not that they're manually in control any more than Neil Armstrong was. They're very heavily dependent on software, but they're kind of involved in a very much richer, deeper way that's, in the case of airline landings, proven to have benefits.
Similar story about robotics on Mars, and I have a chapter on the Mars rovers and how
the scientists who operate the Mars rovers actually work. Those robots are not doing any science. They're doing very, very little autonomously. And they have these very long time delays, 20 minutes up and back, to get the signal back and forth. But actually, if you talk to the scientists who operate them, they feel extremely present on Mars. They are literally living and working on Mars, in this case for 10 years at a time. They have a very strong sense of being present in that environment. They are very deeply, remotely present, living and working through the robots. And the robots themselves are really not doing anything on their own, maybe some basic housekeeping.
So I actually like this statement. It's from a Defense Department study from 2012, which says all autonomous systems are joint human-machine cognitive systems. There are no fully autonomous systems, just there are no fully autonomous sailors, soldiers, airmen, or Marines. And you could add to that lawyers, doctors, surgeons. So on the one hand, the dream of full autonomy is a dream.
I think it's the kind of 20-something engineer, young male dream of I make all my decisions myself. I live on my own. I am totally the master of my fate. When actually the world that we live in is much more a world like this, where we have certain kinds of autonomy and we feel and we certainly do make decisions on our own, but we're also, as people, deeply embedded in social networks, deeply embedded and dependent on others, shaped by others. And it's this mix of kind of network life and autonomy that we live with, not a life of pure autonomy. I used to say in this talk, only Iraq is purely autonomous. You can always find a wrapper of human activity around any autonomous vehicle. Then my geologist friends corrected me. They said, even rocks are shaped and placed by their environments. And so what does that mean? Now, I'm an engineer as well as a scholar. And so I like to write about what other people have done and even what I've done, but I also have a goal of trying to do things better and thinking about how to make technologies work for people in the world today and in the future. And I'll tell you a couple stories about that. So one of the lessons that we can take away from this for engineering systems is this lesson, right? the machines, generally speaking, and I've interviewed a lot of users of all these different kinds of systems, people hate it when machines do something that they don't understand why it's doing it. And you ask any airline pilot, have you ever asked this question? And they'll say, oh yeah, I've asked that question of my computer. In fact, we were flying over here today and we heard it over the radio. There was another plane coming in Nantucket and the controller said, oh, sir, you were supposed to level off at 10,000 feet, but the plane kept descending. And the guy said, yeah, sorry about that, the box got confused. And then he was asking exactly this question. Happens all the time. And people are really good at correcting those errors, by the way. So you need to build systems that are good at explaining to the people what they're doing. And today, a lot of our AI kind of intelligent systems are not very good at this. And the people who design them and build them are not very good at building insight into what they're doing. A lot of airline pilots would say to me, I don't even care if I hate the way they did it. If I just understood why they did it that way, it would be so much easier for me to use. So we're working on one project with DARPA, which is the Advanced Research Projects Agency with the DoD, where actually they've asked us to build a robot that sits in a co-pilot seat and flies the plane just like a person does. That is, looks at the panel using machine vision, doesn't have you don't drill any holes or anything, you don't modify the airplane in any way. You look at the panel, and then it actually operates the controls. And you can sort of turn an old-fashioned aircraft, which the US government has a lot of, into a more highly modern aircraft. And you can kind of decouple the development of the airframes, the actual airplanes, which is a kind of 100-year cycle, from the development of the autonomy, which is a 100-month cycle, not even, it's probably a 100-week cycle these days. And we've been very involved in how do you build a robot like this that can learn how a pilot really operates a plane, not just what it says in the checklists and instructions, because those things don't really tell you, and then actually help the pilot without actually getting in the way. It's not an easy problem to solve, and I won't at all claim that we're there, but it's the sort of forward-thinking thing that goes on in the research world. And then I'll just finish up by saying a little bit about a company that I started since I finished the book, which is sort of how do we take this philosophy of building autonomous systems, how do we think about building systems that are use situated autonomy. They don't try to be lone, independent, perfect autonomy agents, but rather live in embedded systems and live around people. Okay, why might you care about this? Well, right now, if you go into a factory, the robots are all behind a big iron wall. It's not a very efficient use of space. People are not very good and not very able to collaborate with robots in those settings. And actually, there was just a story last week at a mall in Stanford where a robot ran over a little kid. And that was just a simple robot in a mall that was supposed to be, I think, doing some security work, and it bumped into a person, which is the last thing it's supposed to be. We're not very good at integrating robotics into human environments. The stories that are coming out in the news every day these days about driverless cars are, of course, very much about this problem, right? It's one thing to make a car operate on a road that's, in Mountain View, California, where the weather is great and the roads are well marked and whatnot. How many people are here in the winter in New England? Probably none of you, because you come to Nantucket in the summer. But the winter in New England or anywhere is a whole different story. Think about it in the airplane sense. We figured out the full autonomy version of airplanes 15 or 20 years ago. It's not that hard a problem. That is, build an airplane that can take off from a runway, fly through the sky, maybe even avoid some thunderstorms and land at another airport. Not even interesting to people at MIT who work on those problems. Been there, done that. But to do that same task, take off from an airport that other people are using, fly over people's homes, fly through airspace that other people are flying through, and land at another airport that other people are using, that's the situated autonomy problem. We don't even know how to start on that problem. That's such a difficult problem, making just aircraft. And aircraft, in some way, operate in a much more rarefied atmosphere than cars do.
So we're looking at this kind of problems. And beginning to develop technology that allow people to work together.
And I'll show you a little bit more about that in a minute with machines. Our two founding scientific advisors, the people who are my mentors, are Bob Ballard here, who I've mentioned, who found the Titanic, and Dave Scott, who designed the Apollo computer, was part of the team that designed the Apollo computer at MIT, and then actually landed it on the moon in Apollo 15. He was the 7th person to walk on the moon and the first person to drive on the moon. He got to test out the lunar buggy. And we're building systems that allow very, very precise knowledge between people and machines, some just simple electronic type stuff, but it allows a human to walk and be near a robot arm where the robot arm can have a very high level of safety awareness of what it's doing. You can think about virtual reality
and kind of connectedness through those kind of ways. We're working a lot on assembly line things, and
I'm actually really looking forward later this fall when we give the stuff to artists and just let them tell us what it's for. So lots of little small, basically small radars that allow people and machines to live in ever closer collaboration. And so I'm going to close then and open it up for questions, but I want to show you this little sort of suggestive movie that captures some of these ideas in a little visual montage.
What does it mean to be on the cusp of microlocation? It means a new frontier of human-centered design, synchronizing modern technology to create a symphony of applications. Microlocation will drive our next era of data, mapping movements to absolute precision, down to the width of a single hair. Unlocking potential with small, inexpensive sensors. Ubiquitous, functional indoors, outdoors, day or night, in all weather. Harnessing the imperceptible complexities of movement between human and machine, allowing us to remain connected, relevant, active participants in a technological world created for us, ready to construct, collaborate, explore, engage. The opus of our movements, captured by microlocation, becomes second nature. Imagine the possibilities.
Thanks. So we can open up for questions.
What were the ethical issues involved in the police using a robot to shoot that killer?
Okay, great question. What are the ethical implications of the police using the robot to shoot that killer? And I should preface this by saying this only happened about a week ago or less, and so people are still really responding, thinking through, learning a lot more about the episode. I think some people have been critical because it's part of the overall militarization of the police, which is a political concern for good reason. And people have also said, well, if you, and this is something people have said about warfare for a long time, if you make it safer, then people will be more willing to do it. On the other side, people have said, the police are not obligated to risk their lives. Right? So you can say in warfare, and I've written books about this, are you really being a heroic soldier if you're not risking your life? And there's an old debate about that story. The police, not so much. I mean, the police want to do their job and get the job done with the minimum risk to themselves as possible. I actually am not, from my point of view, actually think that firing a gun is one of the earliest forms of robotics, right? A gun is a remote robot where you pull a trigger and a bullet is a kind of autonomous vehicle that has some human direction from the beginning, but may or may not land where you want it to land. And it's action at a distance. And when guns were introduced into warfare, people debated deeply and very fiery, is that really ethical? So it's not clear to me, again, the robot they used is a remote-controlled robot, like a video game. There's no software in there saying, oh, that's the bad guy, I'm going to kill that person. Now, maybe one day there will be. That's a big concern within the military, for sure, and now it's a concern for the police. What I'd say about that is, even if you do have software in there, it's still a human judgment. That human is making that judgment earlier and a different time. All software is deeply embeds the human values. In fact, I was at this conference I was just at in Aspen, and the guy who started Airbnb was up on a panel, and he said, you know, the software that runs Airbnb was written by 3 white guys and encoded our view of the world, and now we realize it, and we didn't, and it turns out it's discriminatory, and we didn't know that. So all software, I mean, the other really interesting one around cars is the diesel, the Volkswagen diesel story. It's not about autonomy, it's about environmental emissions, but there may be Volkswagen diesel owners in this room, ask them what it's like to have software in your car that doesn't share the values that you have. Right? So all software has values. Just because it's computerized doesn't mean it's inhuman. It just means the human decisions were made some other place, probably less visibly. And so if we were to get to a point where you would have a remote police robot that could kill in that way, I think that's a big concern for people because, you know, in the same way that it is in other environments, you just don't know.
I have another ethical question, broader ethical question. In these environments, MIT or technical schools, how closely related is the ethical discussions to the proposal of the idea to build a bomb? It seems like the ethical discussion lags sometimes many years behind the idea. Are we better now working the concert of the ethical discussion while the advancement is moving ahead? I'm thinking the autonomous car. Seems like it would have been more of a heads-up display where the driver, before we take that large of a jump, we would have done the driver eyes has to be concentrated on the road. If, you know, if he's not, if he's asleep, something warm. Seems like the advancement shot way ahead of smaller steps.
Yeah, I mean, it's a great question, big question, and there's at least 2 questions in there. At some level, you're describing what I've done for my career for the last 20 years, is try to teach engineers that all of these early design decisions are not neutral and that they have to think through what they're encoding in their software. And, you know, MIT is okay at it. I wish it was better. I wish we were getting better. I'm not sure we are. There's still a very strong imperative, like, I'm going to build this AI program and it's going to solve everything. And without a lot of awareness, I mean, the big thing these days is data, right? Big data. But all data is very shaped by how it's collected and who collects it. And so if you have an AI system that's based on data, it has all of the pluses and all of the minuses of the data that it lives with. In the driverless car case, you know, we're not there yet. That story is going to play itself out in the next 10, 20, 30 years. And I actually think the car companies, I know they already are internally, and they're going to get there where, again, there was a fatal crash of a Tesla autopilot in May that was just announced last week. You know, the world is going to force these systems to be more robust in the ways I'm describing. People have asked me, I've talked to the Google people at great length, don't agree with them, but I've in a deep conversations with them, people say, oh, do you think you're changing Google's approach? I said, no, I'm just describing how the world works as far as I can. And the world is forcing Google to change its approach. There's nothing to do with me. It's that when you bring a system out into the messy, scrappy human world with all that uncertainty, just certain things happen. And I've concluded that by looking at 30 or 40 cases of that. I think that's going to play itself out as well in the driverless car case.
One of the primary ethical concerns people point to is that people start comfortable with a robot making those decisions, for example, life or death. And I think it's interesting because in the instance of like self-driving cars, for instance, there are what, like 400,000 people killed every year, not only that.
30,000.
Okay, so more or less, right?
Yep.
Sure.
Yep.
So if it's better than that? How do you answer that ethical question? Yeah, we're not comfortable with robots, but if it's slightly better, how do you?
Yeah, that's a great question. Start with a simpler question, which is, can a lot of these technologies make driving safer? I think absolutely, and as well they should. There are indeed 30,000 people killed in the US, roughly 30 to 35, by car accidents. That's a tragic, terrible thing. A friend of mine who is an ethicist says, if an alien race landed and said, we'll solve all your transportation problems and give you this great mobility, we just request that you give us a human sacrifice of 30,000 people a year. We would never make that deal, but we basically made that deal. And it is also correct that many of those accidents are attributable to human error. Humans do a lot of stupid things. They get drunk, they drive when they're not licensed, they drive when they're fatigued. But what we don't know is, and accidents are generally well studied. We know a lot about accidents, they're easy to count. What we don't know is how many accidents are avoided by people being in the driver's seat. And how many accidents happen when there's a subtle, complicated, unforeseen thing that, that even maybe unconsciously we avoid. And by taking the human out of that story, you are potentially unleashing 5 times that many accidents in that case. People are actually really good at that kind of stuff. Like I mentioned with that pilot thing. Oh, the box got confused. Person was in, saw the box was confused, turned off the box. Total non-event. You won't read it in the paper. So not that is an argument against any of those technologies, but we have to be clear that we just don't know. And that Tesla crash is a case last week where something new happened that we didn't expect, that the engineers didn't sense. The radar in the car was looking under a truck and thought it was seeing the road ahead, and the truck above it was just a street sign and misread the situation. And then there are other ethical issues around, even if there are fewer robotic accidents than human accidents, that may or may not be acceptable to people, and the liability story is very complicated around that. So my contention is simply that, look at the lunar landing case. When you are the person whose rear end is on the line, and you're also the person who is physically in the environment, I cannot believe that the amount you have to add to that situation to contribute is 0, right? It might be only 0.001% of value, but it's just everything we know about all of these systems, present and past, says that the people who are on the front line have something to add. And maybe it's 99% automation and 1% human, but there are people out there who are saying it's 0. And, that may be the future of technology, but that's an argument based on faith and ideology, not an argument based on data.
Taking the point of turning it around, is the autonomous car problem, would the autonomous car problem be simpler if all cars were autonomous?
Yeah, that's a great question too. Would the autonomous car problem be simpler if all cars were autonomous? The facetious answer is it doesn't matter, because they're never going to be. And if there's anything we've learned from the ocean or from space, we're always in these hybrid mixed systems, and I think we well should be. Is it possible that I'll be driving down the highway and there's an unmanned Amazon delivery truck driving next to me? That's very likely, right? That probably will happen. It's a lot easier to automate stuff when there aren't human bodies on board and human lives are not at risk. And I cannot see the day where we'll have a totally unmanned fleet. We're just even beginning to learn how an autonomous car changes the behavior of the human drivers around it, and how then the autonomous car has to respond to the changes, because then the people don't behave the way they behave in the database. So there's a lot of that going on. If you could design the U.S. transportation system from scratch, from the ground up, and make every single thing designable by a car, controllable by a computer, but you all drive on Nantucket, that no, I don't see that happening here.
Can you talk a little bit about Hawking's concern about the full development of AI and destruction of the human race?
Yeah, I think it's a bit out of left field, actually, and I don't my personal feeling is some of those concerns are a little bit self-congratulatory. I actually wrote a piece on the web last fall when the book came out that said, you're much more likely to die by a poorly designed robot than by an evil one. And you're actually pretty likely to die by a poorly designed robot. So I tend to be someone who focuses a lot more on the kind of real concrete world. I've spent a lot of time, I don't consider myself an AI person per se. I've spent a lot of time with them lately. I think what we're learning there is there are a lot of different kinds of intelligence, and that intelligence doesn't necessarily mean human. And we're getting pretty good at designing certain kinds of intelligences for certain kinds of well-defined tasks. But the idea of a general artificial intelligence is so far off and so out of reach, and still has, they're not even working on the social awareness that we know is fundamental to intelligence. So I see that some of that as a bit of a red herring.
How and why did the industrial robots move so far away from human beings?
How and why did the industrial robots move so far away from human beings in factories? Simply, it's just safety. I think they're relatively safe now, although I think they came up through a world where, one bit goes wrong and a giant arm. And if you want an arm that does something useful in a factory, it tends to be big and need to lift heavy things, and it can bonk your head pretty hard. There is a whole very interesting world of collaborative robots out there. My friend Rod Brooks out of MIT just founded a company based on that, where there is definitely good progress being made in allowing, a robot that if it bumps you will instantly shut down or won't hit you on the head too hard, or improving the safety features so people can begin to share space. And that's important progress. But the big sort of standard industrial robots are still pretty scary to be around. And that's even true in a lab at MIT. I mean, you have to take, like you do in a biology lab or a chemistry lab, you need good safety practices to work with those things.
As you look ahead for the question, the hot topic today is driverless cars. Do you think we'll be surprised how quickly they get adopted, or do you think we may be surprised that, in fact, maybe they're much longer and further out than some of the more optimistic people are thinking right now?
Well, I mean, a year ago, Google was saying by 2020 we'll have full fleets of fully autonomous cars on the road. This spring, they said maybe in 30 years. So they've backed it off a lot. And now that said, I think there are, again, the autonomy will be successful when it's situated. The case people have used for years is the sort of automated minibus in the Disney parking lot that takes you to the entrance to the park. Structured situations where you can have a pretty good sense for what the task is. Actually, I was talking to the guy from IBM Watson the other day who runs that AI program for IBM. They're focusing on buses to use the Watson technology, because buses, they go regular routes, they go around. And so I don't think there's any question you'll see those kind of applications emerging in cities, in other places where we have well-defined tasks. That's terrific. I think those are all great developments. That's different from what a car is today, where I can buy a car in Connecticut and drive it to California on all those different kinds of roads and in all these different kinds of conditions. So I think you will see these kind of specialized applications quite successfully. And the great thing is, I'm sure it's going to surprise all of us where they really end up being valuable. That's what's fun about technology. We're never very good at forecasting what is really good about them. Over here.
Where do you see robotics going and affecting the medical profession? I hear a lot of talk about how robotics will help in surgery and doing pre-exams on parts ahead of doing the actual surgery. The doctor will actually be able to see a hologram, do the test surgery on the actual heart that they're going to operate on, but that's sort of hearsay for me. Can you talk about how robotics is going to change some of the profession?
Yeah, that's a great question. How is robotics going to affect medicine? Obviously, there are some very successful robotic surgery surgical instrument companies out there. Any number of, particularly prostate surgeries, are being done robotically. The jury's a little bit out in the long term about outcomes on those things and the effects they're going to have on the profession. So you end up finding surgeons who are just robotic surgeons versus other surgeons kind of converting over, and the outcomes are a little bit hard to compare in those cases. I think the example you mentioned is a great one, like simulation, which is all kind of wrapped up in all this anyway. The ability to do anything simulated before you really have to, cut real flesh is a great thing. And there, we actually live right next door to the Mass General's robotics surgical simulation lab. So the more you can do that kind of thing, where you can sort of shift the effort in time, which is one thing autonomous systems are pretty good at. I don't study medical cases per se, although I talk to a lot of people who do on a regular basis, and I think the medical profession will go through a lot of the same things that other professions have gone through, although most of those other professions have kept the people in a pretty central place, whether it's through a kind of hybrid or telerobotic thing. It's one of the things we learn at all this. People are really pretty darn good at a lot of different things. And there are a lot of ways we can make them better and reduce their errors. And I often use the example of chess, where Big Blue beat Kasparov 10 or 15 years ago now in chess. And so the human versus computer chess problem got uninteresting. But today, not a mediocre chess player, but not a top chess player, with a mediocre chess program can beat almost any human chess player or robotic chess player. So the most powerful combination by far is human plus computer playing chess. And that's a good metaphor for what I think you'll see in a lot of these things. Yeah, here.
You kind of addressed as far as aircrafts and how they operate when they lose the autonomy once the human element is placed in them. You referred to the aircraft that you heard in brief. I wonder if human can correct the robotic error. Can robotics correct the human error? For example, the aircraft, whereas one pilot went out to the bathroom in another country, I can't remember which airline it was, and once that pilot was out in the bathroom, the other pilot locked him up. He had a depression issue, still at the helm.
Yep.
And he crashed and killed him. Can robotics in aircrafts correct an error that a pilot like that?
Yeah, so that's a great question. And there's sort of two in there. One is, can the robot help the person and help them correct their errors? And the answer is absolutely. That's one of the things we're working on in our robotic co-pilot thing. And we actually can predict pretty well the kinds of errors people make. You make more errors when you're tired. If the computer is watching you fly all the time, it's not too hard for it to learn and say, oh, you know what? When you're tired, you tend to do this one step a little bit late. I'm going to help remind you to do that a little earlier. That's co-robotics, collaborative robotics, human-robot teaming. People are very interested in that. It's one of the top priorities for the Department of Defense right now. The other question is, like the Germanwings crash you're referring to, is, and it came up actually in the Apollo program, should the computer allow the pilot to do something dangerous? And the ended up with the answer is yes. Because the pilots all said, that dangerous thing might just save our life one day. And the problem with that, of course, has to do with what do you mean by dangerous? And who's going to decide whether the pilot in the cockpit is behaving in a dangerous way or not? And the edges of that decision are the places where people can die or people can live. Now, there is a new system, relatively new, in an Air Force airplane, the F-16, where they have a big problem with pilots blacking out. They pull too many Gs, they black out, and they'll crash into the rocks. And they lose pretty reliably 1 or 2 airplanes and pilots every year doing that. they implemented a system that is able to sense, it doesn't do anything about the pilot. It doesn't observe the pilot at all. It just says the airplane is going to crash into the rocks, and there's a point at which the human is unable to correct that, so it assumes the pilot has checked out, and it will correct away from the rocks. And theoretically, you could program an airliner that it couldn't crash into a mountain that way. But the devil is in the details about what do you mean by mountain? How do you know the pilot isn't trying to safely crash land on a mountain because he has no other options? What if the mountain changed or moved? Or, there's a lot of subtlety in there. And in response to the Germanwings crash, people said, better mental health monitoring of our pilots is a much easier solution and a much more reliable and cheaper one than trying to build. People had this question after 9/11, right? Should you be able to take over an airliner from the ground if it's been hijacked? Well, it's, again, very, very fuzzy and controversial. Well, that means you could hack it, all these kind of things. The human judgments are still in there. You're just moving them around, and sometimes you move them into place where they're not as visible, and that's not always a good thing. Yeah, here.
What effect do you see a world of situated autonomy having on committee meetings?
That's a good question. I mean, at some level, we're there already with remote committee meetings, right, where you can check your email while other people are talking on committee.
Robots have to have a seat now, too?
Well, we have a telerobot in our office, and it's very interesting. It's basically a little iPod on a moving platform, and it's kind of mobile Skype, right? So you can walk around, and one of the key guys in my company is physically located elsewhere, so he spends 2 days a week working from there, and he'll kind of remote in. And there are these telerobots. Some businesses use them, and nobody ever used it. It was sort of a novelty for a few weeks, and it's actually ended up getting stuck in a closet. Not because it's freaky or scary or concerning. It didn't work perfectly. It ended up being more trouble than it was worth, and you probably experienced this. If you work with people you know well, you can do it over the phone pretty well. The more larger senses of presence are more with people who you don't know, and it's harder to work remotely with people you're not experienced with. And I was surprised because I thought, hey, we're going to be a little robotics company. We should be using the latest techniques. And like a lot of technologies, they're not so perfect when they're new. And if it doesn't work every single time the same way reliably, people don't want to bother with it. Yeah, over here in the yellow shirt.
How are the engineering departments at various universities dealing with robotics? Is this something that's part of a general program, or are some universities more specialized in this?
That's a good question. There are a few places you can get a degree in robotics. University is still pretty traditional as far as electrical engineering, mechanical engineering, computer science, so on and so forth. There are people at MIT in all those departments who do robotics, and then they kind of self-organize into labs, but it's not really a degree. And that's true at all the really top schools. They don't offer degrees in robotics. Like a lot of these things, it's a field that sort of stands for a mishmash of a lot of other things. It's a little bit of mechanical design, it's a little bit of AI, it's a little bit of sensor design, it's a little bit of machine vision, and people who do research are sort of specialized in those things. Students love it though. I mean, and high school students in the first robotics competition, and it's a very compelling thing for people to work on, which is a great thing.
We've got a new situation with Tesla and a highly censored vehicle that's highly connected. So now over millions of miles you can watch humans and what they do. And then you've got Google on the other hand who says, I'm going to watch machines over hundreds of thousands of miles or tens of thousands of miles and then simulate what that machine might do in the future. And now that we can watch humans in all these different corner cases over, lots of different iterations because they're connected and because sensors are so cheap, how does that change our learning or our algorithms going forward, or our ability to rapidly adapt these systems?
Yeah, that's a great question, actually, because as I said before, we know a lot about accidents. This is true in aviation, too, and we know a lot less about how people operate in the day-to-day. The airlines record all that data, but none of it's public. Tesla and Google don't make any of that data public either. I wish they would. Maybe they will someday. We will be collecting, just through the virtue of these vehicles out there, lots and lots of data about people, how people drive normally, because that's when all these little subtle things that, I actually saw one the other day, I should have put it up, where there was a street in Cambridge. It's where the Bryn Mawr bookshop is in Huron Square. And I drove by the street, and there were literally, this is the epitome of Boston driving, right? 2 one-way signs pointing in opposite directions right on top of each other. It was beautiful. And what will a machine do for that? That's almost like a Star Trek episode where the smoke starts coming out of the machine. It took me a little while. I looked at it and then I sort of realized, okay, there's construction on the street and there's a bag that was supposed to be covering the other one-way sign that is flopping in the breeze. But that was a pretty complex interpretation of that thing. And we do that all the time really well. But we don't know a lot about how we do that. And we need a lot more information about how that works. So it's great that data will come around and hopefully some of it will be available. Although I doubt it. I think the companies will keep it to themselves because it's part of their competitive advantage.
Are robotics playing a role in artificial limbs and helping people achieve all sorts of activities that they are denied because of their injury or something general?
Yes, absolutely. They have from day one. I was up at Dean Kamen's shop in Manchester, New Hampshire the other day, and he's building a beautiful new artificial limb. So pretty much anything that you see in any of these other fields is going to benefit in those kind of fields. And they're the kind of epitome of, really tight, if they work well, beautifully integrated human-machine integration. So, but then you sort of go a step further, right? And you say, well, maybe everybody should have artificial limbs. And there's a big research in exoskeletons. As workers in factories get older, they're very experienced, they know a lot, but they're not as interested or as able to do the heavy lifting. Maybe you put an exoskeleton around them and you can extend their productivity in interesting ways. Car companies are looking at that a lot.
I think you have time for one more question.
The last question is, you see this in the movies, but I assume in real life at some point, as we use drones to fight our wars, others will use drones to go against the people that they don't like. And so is our military thinking about, instead of putting people in the tanks, sending the tanks out there, and then what about the enemy? They're going to be using drones against us, and more worried about the terrorists not having to get into those vehicles and just sending them along. That's what an IED is anyway, right? It's basically.
Great question, and absolutely right. Yes, that's very scary. The DoD is very worried about that. And you're also right that an IED is a remote robot. No reason to make the distinction. A landmine is a kind of a robot, right? And a self-acting, it makes the choice on when to kill. Programmed by a human on what the pressure point is or whatnot, and there are real ethical problems with landmines. Yes, the DoD is extremely concerned about even simple robots. I mean, you can take a consumer drone and put enough easily accessible explosive on it to ruin everybody's day. Frankly, it's amazing we haven't seen more of it, I think, even domestically. But there's a lot of research in detection and jamming. If you have the Super Bowl or any sporting event. I interviewed a lot of people who we were doing an unmanned helicopter project for the Office of Naval Research, and I interviewed a lot of people who had been in Iraq and Afghanistan, and they said, unmanned helicopter? No way, that's the scariest thing I can imagine. You have no idea what it's like to be on a battlefield and see unmanned airplanes flying around. You don't know whose they are, you don't know who's operating them, you don't know what they're up to or what their capabilities are. Even if they're ours, it's scary. And that's legitimate fear of robotics, right? And people need, again, making those things more transparent to who's friendly and whatnot is part of the job that needs to be done, but it's not a simple thing to do.
Thank you, David. I thought this was a fascinating discussion. Great to get our lecture series started in such a stimulating way. Thanks again.
Thank you.